temperature, but I don't think I wrote anything down. So in the notes we're going to write temperature, and we're going to use the same example the homework uses to explain. So please ask me questions if you were confused. Stop me. I need clarification. N2 plus 3H2. Reversible arrow here, 2NH3. Okay, so here's our reaction. If you look at the top of this sheet, it says 22 kcal. That's an old number. This worksheet's like ancient. Way before my time. I got it from my student teacher actually, who got it from a book that's even older. So we don't do that anymore. Instead we use kilojoules. 91.8 kilojoules. So that's what we're going to put for our delta H. So, who was it? Taylor, I think it was Taylor. Taylor, is this exothermic or endothermic? Actually, it wasn't you, but you can answer it.
Exothermic.
Very good. I think it was actually Zach. Zach, what did I tell you in, I think it was study hall, to help you understand or remember that this is exothermic? Remember what I said?
The end or something? I don't know.
Yep, sort of. So the beginning of the reaction is here, and the end of the reaction is over here. So do you remember what I said about how you might remember that's exothermic? If it's on the right at the end? You don't, it's okay. All right. So the analogy I used early in the year, I told you this, is if this is the beginning of the reaction, you enter here. Enter meaning endo. If this is the end of the reaction, you exit at the end. So exit meaning exothermic. So if you already know it, good. But if you need a little help, maybe that helps. Endo, enter at the beginning, exit, exothermic, that's at the end. So anyways, we need to know this is exothermic. Why? Because if I gave you this reaction and I didn't tell you where to put that, I just said it releases 91.8 kilojoules, you need to know it's on the right side. Because if you don't know it's on the right, this whole shifting thing is all screwed up. So you need to know it's on the right. So I gave it to you, but the Regents doesn't always give it to you. It gives you the number separate. You have to know where to put it. So anyways, it's on the right. Here's the question. If temperature is increased on this reaction, how is the N2 concentration affected? And I'll do this one with you. And here's first question. Second question. If the temperature is decreased, how is the, we'll go H2 concentration affected? So if you don't know how to do this, that's fine. I haven't really taught it, so we'll do it right now. Just copy all that down, please. Oh, and don't forget in lab tomorrow you have your potential energy diagram quiz. Forgot to mention that period too. All right, we all got this down here? Almost. Okay, so again, eyes up here, look up here. The way I teach this is I teach that the 91.8 is kind of like a substance that we can add or remove. That's the only way I think to really learn this successfully at first, until you really understand it. So imagine the 91.8 sitting over here on the right side. So if we heat up this entire reaction, think of heat as this number. So heat is a substance that we can put on, or heat is a substance we can take off. So if we're increasing the temperature like this question says, that means I'm adding more heat. So I'm making that number bigger. Instead of 91.8, which is balanced, let's turn it up. I don't know, let's say it's 300. Okay, just make the number bigger. What should happen to this side if we add more to this side? Anybody? What happens? What? Yeah, it goes down. So how does it shift? Towards the, Jake, you with me? Stay with me. How does it shift? Towards the reactants. Good. Now you can answer the question. So if you know that it shifts towards the reactants, you should be able to tell me what happens to that. If we're shifting this way, what happens to the N2? Either goes up, increases, decreases, or remains the same. I'll give you hints, not remains the same. So that's how I teach temperature, and that's how I want you guys to treat these questions. Find where the energy is. Left or right, it doesn't matter. If we're increasing temp, we're adding more heat to wherever that number is. The number happens to be on the right. So we're adding heat. It's heavier, so it has to shift this way to go back to being balanced. So, Jenny, if we're shifting to the left, so we're shifting left here, right? Shifts left.
N2 would decrease,
Why?
so it could therefore go on that side.
Well, we're shifting this way, aren't we?
So it would increase.
Why?
So what would be on that side?
Right. We want more on this side because we're like this. So we want more over here. So we have to make more, which makes it heavier. So, does that make sense? Good. So we're shifting left because we're making more of this. I like the way you said that. To balance it out. So the N2 concentration increases. Good. So whatever we shift towards, we always make more of. So if I had changed this to H2, the answer would be the same. If I change this to NH3, it would be decrease. So if we shift this way, we're taking this and making more of these. So that's going to decrease in concentration. Just throwing that out there to help you understand a little bit more. I'm trying to here. If temp is decreased, how is H2 affected? Think about it. Okay, so we're back to being balanced. Now we're making it colder. So think about it for 30 seconds or so. If we're making it colder, decrease in the temp, figure out how it shifts, then figure out how that shift affects H2. Whatever you want to do, you can wait to do it later. We only got 10 minutes.
I'll do it what you want.
Good. So answering this in your head?
Yeah, I got it.
Good. I think I already called on everybody at some point here today.
I think it's called fast.
Yeah, good idea. Go ahead.
Okay, so if the temperature is increased in the on the reaction side. Oh, it's number 2. If temp is
I just spent like a few minutes explaining the answer to number 1.
yeah, I understand.
So okay, here we go. We're balanced. So now it's getting colder.
Yes, I understand.
Yep.
Okay.
Tell me how it gets all screwed up.
When the temp increases, decreases. My bad. Yeah, get that out of there.
I know you didn't do that on purpose. Go ahead.
When the temp decreases,
Yep.
H2.
Hold on. First, tell me how the stress screws up the equilibrium. Because right now it's all good. When we make it colder, we decrease the temp. So one side is going to go down, one side is going to go up.
It's going to produce less products.
You're not answering my question.
Well, it's going to.
You may be able to answer it
The
like
left
in your
side
head.
is going to go down. My left is going down.
It's going to look like this.
Yes.
Very good. Let's stop there. So he's right. If we decrease the temperature the way I teach it, and I'm trying to get you to buy into this, is this 91.8 is sitting right here. If we take some of that 91.8 off, what was that? Somebody
Jackhammer.
outside with a chainsaw?
Chainsaw.
I know it's not.
That is
Wait,
like.
I know I shouldn't be on my.
It's like a
Go ahead.
screwdriver.
Said he's like this.
I was joking.
No, we're learning up here. You can't say
Yeah, y'all have to win. We're learning.
He's the wall.
Back to this. If we take some of the 91.8 off by decreasing temp, so we're decreasing that temperature, that amount of heat. Not that that's not temp. We're decreasing the heat. So we're taking some off. This happens. Very good. So now continue. How does it shift to go back to equilibrium?
I mean, the H2. Well, more react.
You just told me
More
this is what
reaction
happened.
create-
How does it shift to go back to being balanced?
Well, more reactants react to make more.
So which
heat.
way are we shifting?
Back to the right.
Very good. See, there's steps here. You may be able to do it all in your head, but I'm doing it in steps. So we're shifting right. So now answer the question. If we're shifting this way, using reactants to make products, what happens to the amount of H2?
It decreases.
Decreases, very good. Good job. Decreases. That actually worked out well. I explained everything in the steps that you guys, I think, need to do it in. So that decreases were like this. It shifts this way, meaning you're using this up. So these two both will decrease. Okay, questions with that one? We're moving on. Pressure. So your homework, we'll practice more of these temperature questions because we're done with the notes with that. Only a couple examples there. All right, pressure. Here we go. First of all, Steph, pressure only affects what? Gases. Jake, why? How come pressure only affects gases?
Molecules can move together.
Very good. Molecules can move more freely. They have weak forces, a lot of spaces between them. So let me write you the kind of the law, the rule here, and then I'll explain it. So if the pressure on a system at equilibrium, if the pressure on a system at equilibrium is increased, underline that word increased, the equilibrium shifts towards the side with fewer number of moles. And I'll share my mistake, my little kind of screwed up today writing on the board. By mistake, I wrote a pretty bad word on the board. With the word shifts, I left the F out. It was pretty entertaining.
How did you do that?
I have no idea.
Did you get it on film?
And I think I just didn't like curl it. So, anyways,
Did you get it on film?
no. Yesterday, or no, 2 days ago in my general chem class, I was talking about nuclear chemistry, nuclear power plants, and the one in Japan, Fukushima. I almost messed that one up. I was close, which makes no sense. But
How do you spell
spell it.
Fukushima?
Well, it's F-U-K, but anyways, I felt like I should share that with you guys. It was entertaining. Back to this. So write it down. Let me explain. And has anyone seen? Which one was it? I think Star Wars: Return of the Jedi.
Yep.
Which goes right at you.
Has anyone seen the first three from years and years ago?
Yep.
Or at least okay. The one where they're in the trash compactor.
Yep.
And there's like a monster trying to get them, and the walls are coming in, and they're
Pretty
getting
sure
crushed.
that's 4.
And
Edwin said it was
Pretty
4, not
sure
Jake.
that's
Edwin
4.
did.
It was New Hope. All right. So yeah, I knew it was either the first one or the third one. So and he's like on his thing talking to C-3PO or R2-D2 to stop the walls or whatever.
Yeah, but
This
it's not
always
the first
makes me
one,
think
the
of
third
that.
one.
Why does this make me think of that?
Because
Because
it's
the
pressure.
gas is getting compressed.
Right, so pressure. So the analogy isn't completely crazy. Now stay with me. So what are they trying to do? They're trying to like prop things up to brace the walls. That's going to be impossible. So stay with me now. Forget Star Wars for a second. That's just for fun. Back to this. Let's say our walls and our ceiling and floor started coming in on us. So we're gas particles, and we're
I'd get out
starting
that
to
window.
feel the pressure. What are we going to do?
Jump out the window.
We're going to get out of the window. Why?
I don't know.
We don't want to.
Because we don't want to be squished to death.
So we
right?
rather fall
Yeah, it
to our
hurts a
death
little
or
bit.
break
So-
over.
No,
so-
you just gotta be the last one to jump
What
on the pile.
What is the analogy? Stay with me. The analogy of the room closing in on us have to do with this. Besides the fact the room represents pressure being increased. Read the whole thing. Us going out the window. What does that have to do with this?
Gas is like, man, I gotta get out.
Gases have to get out, right? Okay.
Wait.
If you look out the window, you looked out the window. You see any people out there?
No.
No.
But we
So
know there
let's
is
say,
someone
stay
out
with
there.
me. So right now there's how many of us in here? Like 20? Let's say 20 of us.
16.
16.
16 guy.
2, 4.
Okay, all right, good enough. It doesn't have to be
8.
perfect. So we have 16 gas particles in this room. Think of those as moles. So 16 moles of gas. How many moles are outside? None. So if the pressure is put on us, why do we want to go outside? Because there's more
Here's nice.
space, more room. Stay with me. The analogy really helps you understand. If we start feeling the pressure of the room collapsing on us, we want to get out where there's more room. We'll feel more comfortable. Gases are the exact same. If you put a lot of pressure on gases, they always go where there's more space, which means fewer number of moles. So if you have a scenario like this, look up here. You have a lot of dots over here, a lot of particles over here, not as many over here. And you start putting pressure on both of the sides, even though all of it's feeling pressure, there's more space over here, so some of these particles are going to try and escape, so they have more space, so they go to the side with the fewer number of moles. That's the best way I can explain what this means. So in a reaction, let's say here's your reactants and your products. If you have more reacting particles and less products, the gases on the reactant side will actually start to create more products because there's fewer moles and it gives them more space. So I hope that makes some kind of sense. Let me write a real question now and see how you do. All right? So that's the explanation. We'll get at least one question down because we're running out of time. So here we go. So let's use, we use the same example. N2 plus 3H2, reversible arrow, 2NH3. Here's the question. We'll get one down here. If the pressure on this reaction is increased, how are the following, or how are the following affected? N2, H2, NH3. I know I'm going quick here. Try and get that down as fast as you can. I want you to have some sort of reference. I don't know how many of you do this, but when you do your homework and you're confused, I want you to look at your notes to help. So this question should help on the pressure questions on that worksheet due tomorrow. So I want to make sure I give you the answers. So I'm just going to plow ahead here. If we increase the pressure, which way are we shifting, left or right? Remember, it shifts to the fewer number of moles.
All right.
We're going this direction. There's 2 moles versus 4 moles, right? 4 versus 2. So if we're shifting to the right, what's happening to the N2 concentration if we're shifting away from it?
It is going down.
Decreasing, because we're shifting away from it. What about the H2? We're shifting away.
Decreasing.
Decreasing. What about the NH3 concentration?
Decreasing.
It's increasing because we're shifting towards it. I know that's annoying. Okay, get all that down. Then we're done. Don't forget that worksheet. I will not be after school today.
I'm gonna call you Mixology.
Mixology?
Yeah, because you're an ology.
Thanks.
Nah, you can come up with a better one.
I think you should start selling rock candy in bags.
Make rock candy?